This is my presentation, the biogeography of sub-Antarctic giant kelp, from Darwin to satellite monitoring and back again. So let's start by the very beginning. A couple of years ago, I was working for a group working on the voyage of the Beagle. So I had to trace the route day by day, looking at the diary of Charles Darwin. And they spent in their expedition like 3 or 4 years at the southernmost coast of South America, including Tierra del Fuego, the Cape Horn, and the Strait of Magellan. I was super interested in this expedition because it's very, it's full of very interesting details. But one thing struck me the most. This is a paragraph of the Voyage of the Beagle about giant kelp. So Darwin says, I can only compare this great aquatic forest of the southern hemisphere with the terrestrial ones in the intertropical regions. Yet if in any country a forest was destroyed, I do not believe nearly so many species of animals will perish as will here from the destruction of the kelp. Amidst the leaves of this plant, numerous species of fish live, which nowhere else could find food or shelter. With their destruction, the many cormorants and other fishing birds, the otters, seals, and porpoises will soon perish also. And lastly, the Fuegian savage, the miserable lord of this miserable land, will redouble his cannibal feast, decrease in numbers, and perhaps cease to exist. Well, this is terrible in terms of people, but it's great in terms of kelp. Let's say something about these people. They weren't absolutely not cannibals, and weren't not they weren't miserable at all. They were super well adapted to the harsh conditions of the southernmost coast of South America. They were killed by the Europeans and their descendants, like the Chileans or Argentinians, and not by the destruction of the kelp. Having said that, the bond between people and kelp has been very old. For thousands of years, people have collected kelp from the shores, and this is part of their culture, including medicine and food. But in the sub-Antarctic latitudes of South America, Falklands, and South Georgia, we have no records of kelp forests, like a map of the extent of kelp forests in these areas. And also, we didn't have any trends. So this was largely part of the mystery of this ecosystem. And in the central and northern parts of Chile, we had the problem that kelp forest is harvested without regulations, or with little regulations, to be fair. But now they are facing an enormous decrease in the numbers of the total extent and biomass. So this is an ecological collapse. So I applied to Oxford with the idea of studying the extent of kelp forest in southern Patagonia. But when I started this research, I had the problem that using satellite images weren't good enough because, well, these areas are always covered by clouds. And also the water reflectance and so many problems. And also the method, because working with satellite images makes very hard to validate this without ground truth data. So in this example, you can see in red pixels the supposed area of kelp, but all the areas in pink or green are part of the uncertainties. And in this coastline, it's almost impossible to go and see there. So I started by looking at known places in other parts of the world with kelp data. And now, well, the map is facing south because in the south, the planet is oceanic. So I'm just presenting another way of seeing the planet. And I made an average picture of all the, I made an overall picture of all the typical signatures of the many classes of kelp forests. Sorry. Okay. Yeah. So there are many things here in the in this graph. You can see the typical signature of kelp forest and other things. Let's focus here. In the green square, you can see the reflectance of coast and land vegetation. This is both signatures are above a certain threshold. So I max the threshold to take all this stuff out. And in the red square, you can see the reflectance of giant kelp and green algae, which has a difference between the red area of the spectrum and the red area of the spectrums. Using filters for different formulas of vegetation indices like floating algae index or NDVI, and also a formula I created, kelp difference. You can also mask what is kelp of what is not. So I had to validate this. We went with other groups to Central Chile, Patagonian fjords, the Strait of Magallanes, the Beagle Channel, and the Falkland Islands. So here's some pictures. From one side, the Beagle Channel in winter, and on the other side, the Strait of Magallanes in summer. In this case, this is the validation process. So a typical kelp forest, you can see here outlined in black in the graph A. In B, C, and D, you can see the filtered vegetation indices, and the match is more or less okay. And the overall accuracy of all the known sites, the ground truth data with all this process is fairly high, is above 80% in all the cases. And in low resolution, like extrapolating this filter algorithm to other places of the world, worked also more or less okay. So as a result, we have now a high resolution map of the total extent of this ecosystem for the entire planet. This is published in a paper for remote sensing, and also it is on an online link if you want to have a look. Okay, but something that was very important, and it was very obvious to me when I was diving and exploring this kelp forest, was that the forests were shaped to the landscape around. So the areas that were facing the open ocean were like forests with very tall and thin plants, and the areas that were inside the fjords with more sediments, the plants were like smaller and the leaves were larger, like trying to get as much as light as possible. And also I had this very old question, where this forest of Darwin? So just because of the sake of luck, I was invited in 2020 to give a talk for the Hydrographic Office of the UK. And I told them about my obsession with Darwin, and they said, "Well, if you're so interested, why don't you come and see the original charts of the Beagle expedition?" So this was the beginning of a very interesting research using about 300 kelp forests from Patagonia, the Falklands, and South Georgia, and also comparing the nautical charts of the Beagle expedition, some other nautical charts made in South Georgia, area photogrammetry archives, and past surveys to see the persistence of giant kelp, and also the spatial patterns. So I separated or classified the kelps according to the types of currents, the slope class, the geoform, and the exposure. And as a result, using these variables, we could calculate a typical forest size according to the characteristics of the coastline and how exposed it was to the ocean. So the main factors to predict the kelp forest size was the exposure to the current and the type of ecoregions. So channels and fjords of southern Chile and South Georgia had more prevalence of small forests, so smaller than 7 hectares, which is the median, whereas the exposed areas of channels and fjords and the Falkland Islands have more presence of very large forests. So in very simple terms, when the extent of the shelf or the slope was low, you had more extent for kelp to grow. And in vertical walls or overhanging walls, like in the fjords, you had less extent for kelp forests. So, and also, well, and something that was very important was the exposure to the ocean, because more exposed. So you have more renewal of fronds, and the fronds were then taller and thinner, as I told you before. And about the persistence, we compared the drawn kelp areas, which are here in this map outlined in red, and the current extent of kelp forest using with these red pixels. So the extent in shape and area was more or less okay, was more or less matching the old records. So this is an example here in Wollaston Island in the Cape Horn archipelago, where the Beagle expedition stayed there for about 5 days and shared some time with some local Fuegians. So they drew in this map, number 1, you can see the area and the area of the kelp, and the satellite detection filters show that kelps are standing in the same places. And well, the local people left, but their ecosystems, the typical ecosystem is still there. So in average, we have that they are matching in 84%, 98%, 91%, and 62% in the same areas. This is also uploaded into an online map if you want to have a look as well. And this paper is now approved for publication for the Journal of Biogeography. And well, an important question here was why these kelp forests were standing in the same places. So the reason is because the sea surface temperatures are more or less stable. And also in the local trends of sub-Antarctic kelp are indicating that very extreme events of marine heat waves are in existence since the great El Nino year of 1998. But on the other hand, we have more extreme cold events, extreme cold spells in the southernmost latitudes. And this is probably related to a shift northward, the polar front, and also an effect of the glacier melting in the fjords, an effect called freshening of the waters. So kelp forests here are less stressed by heat waves, which is good, but also are facing more threats, or maybe we have more challenges to understand what is going on there, because we have more effects of storms and freshening. So in conclusion, as Darwin himself said, in a long voyage, the map of the world ceases to be a blank. it becomes a picture full of the most varied and animated figures. And the first conclusion is the combined extent of the giant kelp in the Chilean fjords, Falkland Islands, and the island of South Georgia is more than 8,000 square kilometers, which accounts for more than 47% of its known distribution. The ocean currents and exposure, together with the main geomorphological settings of the coastline, are the most significant factors predicting the spatial extent of kelp forests. The majority of the historical records match present time spatial patterns, despite the natural and human changes that have occurred over the last 2 centuries. And southern Patagonia might be a climatic refugium for giant kelp forest. So as in a whole, the sub-Antarctic giant kelp is one of the most pristine marine ecosystems on Earth. And that's my presentation. Thank you very much.
Wonderful. Thank you so much, Alejandra. That was really interesting. So as before, it's time for some discussion now. We have about 10 minutes. And if anyone has a question, please stick up your hand or drop a question into the chat box, or simply unmute yourself and dive in. I can see that Jepe's raised his hand. Jepe.
Yeah, hey, Alejandra, what a fantastic presentation. Thanks a lot. I was wondering, from a rewilding perspective, I think it's interesting to know, like, what is the potential distribution of well, different types of ecosystems, right? But have you thought about mapping that? Like, what is the you seem to know pretty well what governs the distribution of the kelp forest, at least where it is still found, right? But could you somehow imagine that you could figure out, like, what is the restoration potential of kelp forest around the world?
Well, this is another challenge. We don't know what is the restoration potential. We still have to study that. And this is one of the reasons why I'm going to British Columbia, because they are trying to develop some techniques of restoration, and we are trying to find out what are the most significant factors predicting the success at repopulation. Something that we still have to do in Chile. But the first step in Chile will be like protecting the areas, like defining marine protected areas and having more, more constraints at harvesting kelp.
Super. I've got a question if no one else wants to jump in now. So, as someone who knows really nothing about kelp, can you tell me about this? Is there any seasonality in how it looks from satellite? Like, normal, if we think about the trees that we're familiar with, a lot of them shed their leaves in autumn, of course, and photosynthesize in the summer. So does kelp show a seasonal cycle like that at all? And does that affect the way that you would process the satellite retrievals, for instance?
Well, yeah, any species has its own life cycle. So some species are seasonal, some species are annual, some species are permanent. So it depends. I'm working with giant kelp, which has in some cases an annual cycle, and in some cases are permanent. But the good thing is that they are always making a very clear canopy on the surface. So they are very distinguishable when you are looking at them with satellite images. This is not the same as when you are looking at, for instance, kelp forest in the UK. You can see kelp forest just in the intertidal areas, but not in the subtidal areas. And this is more complicated. If you're trying to do a map of that, you should take some underwater surveys, and this is always problematic, as you probably know.
So they're always quite visible from satellite, regardless of the season, because they make this canopy at the surface.
Yes.
Okay, and so is the satellite retrieval, obviously it takes color information. I'm wondering if do you use that color? Well, you showed those images with the NDVI, for instance. I was just wondering if that changes, or are you just looking for patches where there's clearly something?
Yeah.
But,
yeah. Well, I made an average image, so taking all the zenith angles and also all the tidal heights to just get a normal picture of it. So I'm not taking the seasonality, because in the very south, as it's always cloud covered, it's very impossible to see the typical trends. So yeah, this is also a challenge. Maybe using more drone images of the areas at different seasons, days, times of the day, you will get a better picture. But I started by just making the first step.
Sure. Thanks. Got it. Okay. Anyone else?
What is the next step for kelp research? What are the loose ends to tie now?
Yeah, well, what is the effect of this very interesting trend of more marine cold spells, or these extreme cold events? Because it's something that we haven't seen before in any other place of the Earth. It's super different as all the rest of the planet. And the effect of the northward shift of the polar front from the Antarctic to the sub-Antarctic, this is something new. So this is the next challenge, understanding what is going to happen to these kelps. Probably with more storms, you have more movement, like wave movement, and the plants couldn't recover after a storm, after storm. So probably they will face like more mechanical movement and yeah, stress, like physical stress.
Super cool. Thank you.
Thanks. Maria?
Yeah, I was just wondering what you're saying about the cold spells in that latitude. Has any other research been done? I mean, has anyone else picked up on this, either on just a sort of abiotic level, or in terms of maybe terrestrial ecosystems, or generally ecosystems in that area? Has any work been done on that, or is this still very new?
It's very new. It's very new. No. Well, working in Patagonia, this is something that is interesting, because doing something in Patagonia is I think is the last frontier for environmental studies in the world. Like few people are working there, and all the studies are new, so many things to still develop there.
I thought it was really cool that you could find many of the historical forests that had been observed by Darwin. And that also suggests that these forests are kind of stable where they are, and they don't like to expand or move around too much, right? So that are they kind of like self-sustaining or self-supporting? I just wonder if if that provides them with some resilience, or if actually that makes them more vulnerable, because if you get below a certain critical mass, it's hard for them to adapt.
Yeah, it all depends on the geomorphology under the sea surface. So they are always attached to rocks, and unless there is a movement made by people, like making infrastructure or moving or dragging rocks, the kelp forest will stay there. And this that's why I studied the typical forest size, to be very sure that the forest will stay at the same places, because geomorphology doesn't change in 200 years. It takes longer times.
Right, so their locations are very much dictated by the nature of the geomorphology.
Yes.
Yeah.
So do you think you could plant further forests by introducing rocks in areas that, for example, are limey or muddy?
Yeah, this is something we could develop. Yeah, why not?
That would be interesting in case because what you were saying, Sam, about make them more resilient or more vulnerable, that they've been in the same place for 200 years. To it makes me very scared. It makes me very scared because if those forests we start seeing them disappear in the following years because of whatever reasons, what is their potential to expand? They don't seem to have that much potential to expand. But if they're by rock,
yeah, but also we still have to study more the coastal geodynamics. This is complicated because usually when is a beach, you always have the idea that the force of the waves it doesn't have enough energy to drag like big rocks, right? And where there are rocks, obviously it's because there is a potential of wave movement and the wave energy. So you always have to be very clear about all these dynamics and the energy that is there. So if you put rocks, probably you will put like a potential of more dragging more movement of rocks around the coast and maybe creating a more damage than a help. So this is something that we still have to study.
So interesting. Thank you.
Let's go to Mark for a final question.
Yeah.
Hi, Ale and everyone. Just a short remark about this long-term persistence. Rather than a question, it's just a point in the sense that this is a comparison between time shots which are 200 years apart, and whatever happened in between we don't know, and we know that kelp can grow very fast. So the fact that they are in the same place doesn't mean that they have been there all the time. It might be that they have been, due to storms, for example, unusual storms, they might have been completely gone, and then they have the capacity to grow back quite quickly if there is kelp around to allow that. And we know that they move around pretty easily, kelp in general, so that dispersal is not an issue. So in this aspect, we decided not to really talk too much about resilience, but to talk about the fact that they have been found, existing in these places in these two time shots, which is a bit different from having a continuous time series. I don't know if Alejandra wants to comment on this in particular.
Yeah, about drifting kelp. This is something very interesting. There are some samples found in Antarctica from bull kelp. Bull kelp has a structure that floats on the ocean, and this is something very important because between the sub-Antarctic and the Antarctic there is this boundary, which is the polar front, or the sub-Antarctic the Antarctic circumpolar current. And this is also complicated because if there are animals that are attached to this kelp and going to Antarctica, you are facing the problem of expansion of invasive species to Antarctica. So something to look natural for possible stressors.